Okay, so there's not enough clearance for any of my regular pullers to get in here on this bearing cup. So I've got an idea. I know I can, if this fails, I can just come in with a TIG welder and just do some welding on this this bearing cup, and it'll shrink it down. I should be able to get it out, but I want to try this first. I kind of got this idea watching Mark over at Winky's workshop. He used something similar. So I put these bolts, these are grade 8, in the lathe, and kind of cleaned up the underside of the heads and took a little off the top of the heads, so they actually will fit behind that bearing race and grab. And this is an old steering wheel puller, so all I did was just drill it and tap it to fit my slide hammer. So these bottom ones are in there. This one's got a slot, so I can slide it up. Oh, that's nice and tight. Okay. All right, let me get the slide hammer. Taps. Wow. Okay, yeah, so we are moving. Okay. Put a couple wedges under our wheels. I don't know how good they're going to hold. Well, that didn't hold. But we are moving. We've moved about, not quite a quarter of an inch. Alright, I got this reset. I had to rotate our bolts because it is putting a hurt on the heads. Alright, let me reset everything. Doing a little bit of a plan B experiment here. It's actually working. The race is moving. Okay, that's as far as I can go without putting some blocks in there. Okay, that's getting there. Okay, I modified our spacer block. Let's see if we can get this thing out of here. It's in there pretty tight, so hopefully it's just because it's been in there a long time, maybe a little bit of corrosion or something, because it's definitely tighter than what you would normally find on a bearing cup. Almost there. There we go. Okay, it looks like we can hopefully read that number. All right. Yeah, so we'll probably just weld on that other one to get the other one out. But I was worried about maybe destroying the number, and I need to be able to order a couple new ones, obviously. I'm going to try this again on this rear bearing. Like that. I had to modify our puller bolts just slightly. We don't have as much clearance on this one, so I had to take a little off. Plus they needed to be cleaned up. Okay, we got a much better fit now, so let's try this again. That one was way easier. Let's see if I can get these internal seals out. There we go. Still haven't figured out if that's leather or felt. So these seals are just leather strips. This one's really stiff, so yeah, I think we'll just make new ones. This one here is still pretty pliable, but if we're going to make one, we might as well make all of them. Did a little wipe down with some solvent and got this base tray cleaned up a little bit. So we're down to the last thing here, and that's to get this label off. It's held on with drive screws. Normally what I do is I just take my Dremel tool and cut a little slot and then try to unscrew them just like a screw. But these are really dinky, so I think I'm just going to center punch them and then just drill them out. I think that's the safest way to go. Well, I went to plan B. Turns out these little drive screws are really hard. I couldn't even center punch them. So I just got in behind there with a real sharp chisel and was able to pry them out. We did have a little bit of pull out. These were hammered in there really tight, but I think I'll just do an oversized drive screw when we go back and it'll be fine. We did our oven cleaner and our wash down, and it came up pretty good. Got most of the nastiness off of there. Let me spin it around for you. Yeah, so much more pleasant to work on now. What are you doing, Ethan?
I'm taking off all of the paint.
Okay, you're doing a good job. Thank you for the help. All right, well, what do we got to do first?
We gotta take off the pulley.
What's in there?
A set screw.
Okay. Is that heavy?
Yeah. I'm trying to get this one off.
Whoa, wait a minute. Righty tighty, lefty loosey. Here, let's flip the motor, it'll be easier for you.
Yeah.
It's a little too tight to get the box end of the wrench in there, huh?
Mm-hmm.
You gotta let him do it so he can learn. Ooh. There we go, we're getting some movement. This motor's been repainted. Yeah, I wasn't sure if the paint was holding on to it. Okay, now I gotta be careful. I don't want the centrifugal switch to fall out of the back. Well, I don't think we're gonna have any choice. Yeah, let's just see what happens here. Okay, so we're hitting something there. put some punch marks so we have alignment for going back together. Yeah, we're hanging up on the centrifugal switch. So it looks like the entire centrifugal switch assembly, well, at least the electrical part of it, is all mounted on this Bakelite plate inside there. And I think I just take these two screws out, and this whole plate will be loose. That one and that one. Getting it lined back up, going back in will be fun. I had to gently pry to get the bearing to finally pop out, but finally got it. Okay, so there's our end bill. And our centrifugal switch. Terminal board. Okay. That bearing is shot. This is probably more for me, just so I know what's going on here when we go back together. So this was terminal number 5 up here, and it's never had anything connected to the back side. So it was probably just a junction point. And we've got this wire right here, which probably landed on that at one time, and it goes right into the stator. So I'm guessing this is probably the start winding. Okay, and then we've got this other wire here that goes behind the board, and it lands on the centrifugal switch. The other side of the centrifugal switch comes out here, goes to the capacitor. Other side of the capacitor goes straight into the stator windings. Okay. All right, so I took the copper jumpers out that were between terminals 2 and 3. This is terminal 1. The number's behind the screw, so it's hard to see it. It's 1, 2, 3, 4. All right, so then if we ohm this out, so I ohmed it out before I took the jumper out, and we have 1.7 ohms through the run windings. So now if I go here to number 4, it should be nothing to 3. And I know you guys can't see this. Let me get it over here. There we go. Okay, 3 and 4, there's nothing. And now 2 to 4, if I can get a good connection here, get past the corrosion. 0.9, okay, that's about right. In the ballpark, okay. Now if I go to 3, it should connect to 1. Okay, I hit that with a wire brush. Let's try it again. There we go. Okay, so our windings go between, and it's split because it's dual voltage motor, between 1 and 3 and 2 and 4. So we've got to put our little copper jumpers, and the way it's configured, it's the only way they're going to fit. So they go like this, right? If I can keep them from falling off. So that should be the correct configuration for 120 volts. This would be our 2 incoming power wires, or one's going to be neutral, one's going to be hot. And then these 2 are the start winding. So basically you just parallel the start windings with the line voltage. And then if you want to reverse the motor, you flip-flop these two like this, okay? And then it'll start the other direction. So we do all that up at the drum switch when we get to that point. All right, time to get this bearing off of here. I did have a viewer, and I will contact them, offer to take a picture of the wiring on his motor. He's got the same motor. I think it's on a lathe, but it's the same motor, so we will verify. Normally I like to use a 3-jaw puller, but this one was already out, so let's just give it a try. There we go. There we go. It's another one of these extended races. Nice. Wow, look at this. This motor uses copper rotor bars in the rotor. Wow, that's old school. Yeah, normally it would be aluminum in most common motors. Yeah, you wouldn't see copper until you get into some real high-end motors. Yeah, that's really unusual. And then look, this has all been welded. There we go. And that bearing's toast also. Could just be the dried grease. They're easy to change, so we'll just change them. Let's put something more slippery underneath it. Okay, let's try that. There we go. I picked up a few estate sale items the other day, and I thought I'd leave a few of them out because a couple of them are interesting. Well, first off, I had to pry that one out of the seagull's hand, but I got it. Yeah, nice little Armstrong jack. That's a little beauty right there. And I've got a couple of hook scales, but they're the skinny ones. So I saw this hook scale, so I grabbed that. It's also got the drill point gauge with it, so that was a nice find. And then I got a lot of scales, but I didn't have one that had a nice metric scale on it. So yeah, there you go. So now I've got a good metric one. And while I was looking at that, I remembered I had this one. Okay, this is the third time filming this, so hopefully I'll keep it in frame. So it's a Pioneer brand, made in USA. It does have metric on the top, and it's 1/2 millimeter increments. But then this lower scale, which is imperial or inch, has got some interesting graduation. So this first section is in 50ths. I'm sure it's still in frame there. Yeah, this section is in 50ths. This section is in 20ths. And then here we go, tenths. And then we got the more common 64, 32, 16. So kind of an interesting scale. And on the back side, there we go. On the back side, we got quarters. So you got 2 quarters, 4 quarters, 6 quarters, 8 quarters, 10 quarters, 12 quarters, all the way across. And then going this way, you got eighths. So you've got 4 eighths, 8 eighths, 12 eighths, 16, 20, 24 eighths. Yeah, kind of interesting. And then this side, you got 3/4 and 3 eighths going this way. So if you're working in just, you know, fractions, you can just go straight across. I thought that was pretty cool. I didn't have one of these 5C centers, so I grabbed that. This could be pretty useful. You know, you can put that in your 5C chuck in the headstock, or you can put it in like a spindexer. You know, so now you turn your spindexer into a tailstock, or you know, or working between centers. So that was a nice find. Grab that. Also grabbed a set of these small Starrett V-blocks. Somebody made these little, I don't know if they're nylon, some type of plastic protectors for the screws. That's pretty cool. Yeah, I didn't have a small set, so nice to find that. This was really interesting. It's a itty bitty little feeler gauge set, and it's in, you know, imperial, thousandths, and it's also in metric. I thought that was really neat, so I had to grab that. There's no maker's mark on it, so I don't know, but it looks like it's really good quality. I think the screw has been replaced. I don't believe that's original. Yeah, but that was cool. And then I grabbed a set of these carbide little mini drills, and there's also a little container of them as well. So I don't know about you guys, but I break these things just putting them in the chuck, so it's good to have extras. This was kind of interesting. Let me get the protector off here. So it's a little chamfering tool, shop made, and it's really, you can barely read it on here, but it says 30 included, so 30 degrees included. And somebody, you know, turned this down, split the end, brazed on a piece of tool steel, and then ground it to profile. This is a relief. I figured this out. They had to grind this relief so they could get the wheel in there to cut the back rake or the chip breaker. I guess it would be a back rake. But pretty neat little shop-made tool. I thought this was kind of clever, so I had to grab it. So it's just your typical tap handle or wrench. I guess it would be a wrench. But somebody added these extensions. Little piece of tubing with a slot and a screw. So I thought that was pretty neat, so I had to throw it on the pile. Yeah. So this is just your basic, garden variety tap wrench. I did grab a couple other ones. So I have a lot of these. They're just like box store style or garden variety tap wrenches, and they're kind of crudely made, and they work. They get you by. But I found a nice Starrett one. Okay, and the higher quality ones will have floating jaws. So let me open this up. Hopefully I'm in frame here. See if I can do this without the parts flying all over. Yeah, so you see it's got floating jaws in here, and there's a kind of like a torsion spring between them. Yeah, so really nice quality. Of course, it's Starrett. Yeah, so these are way better than this style. So I didn't have a good one in the small size, so now I do. Okay, and then just for comparison, well, here's another one I found. This one is unbranded. I mean, it's probably a copy, but it's well made. It's got the floating jaws, so you know I grabbed that also. And then I've had this one for a long time, and this is a Craftsman branded, and it's got the nice floating jaws, but it's got a ratchet mechanism. So right now it's in the lock mode, so it just works like a regular tap wrench. But then you can flip the lever here, and you can go forward, or this would be forward or right hand, and then you can flip it the other way, and it goes left hand. Yeah, so kind of a neat little wrench. Then I also grabbed this little pan of ice, and I just now mounted it on this piece of scrap plywood. So yeah, it's a nice little, you know, swivel type vise, decent quality. So yeah, so what I'm going to do with this is for my grandsons, so it's going to go to their house, so they've got a little vise they can work with. The older one, he does HO train, so he's always working on them. And then the younger one, he's trying to do everything. He's learning, but yeah, this will be nice for them to have at their house. I don't remember if I showed this or not. I showed it on Instagram, but I did score a baby bullet with the power arm base. Yeah, that was a nice find. That was a while back.